Good afternoon, everyone. This video is made for September 3rd, Thursday class. In this video, we are going to cover section 2.3, solving linear equations using both properties of equality. It means addition property and multiplication property. We learned the two properties on Tuesday. We have a guideline here that we can follow when we need to solve a linear equations in one variable. Step 1, simplify each side of the equation separately. Step 2, either use the properties, addition properties, or my transposition of terms to collect variable x on the left. Step 3, combine the like terms and isolate x on the left. Step 4, if you have extra time, you plug in your proposed solution to see if the solution satisfies the equation. If it does satisfy the equation, then the solution is correct. Otherwise, it's wrong. You have to find out which part get wrong and you have to fix it. So let's see number 1. We have 3x minus 2 equals 5x minus 8. As I mentioned on Tuesday, we have 4 terms. We have 4 terms in the equation. I'm going to color them blue, yellow, pink, and green. We skip step 1 because we can't really simplify either side because they are already simplified. And what happened to step 2? We need to collect variable x on the left of the equation. So the equality symbol serves as an anchor. I mean this word. It will stay there. It will stay there all the time. And what changed will be the location or the side of those terms. We can see the blue term and the pink term contain x. So we want them on the left. What we can do is we copy 3x. We copy the blue term. And then we move 5x, the pink term, over. Please don't forget to change the sign in front of it. We move 5x over, and we flip the sign in front of it. So 5x on the right would become negative 5x on the left. On the right hand side of the equation, negative 8 stays. Nothing changed, so we copy it. We want a negative 2 in yellow, the yellow term on the right hand side. Because look at step 2, isolate the variable terms on one side. We are using the transposition of terms because this technique is more useful. So how do we move the yellow term over? Just move it and change the sign. You move a negative 2 over, flip the sign in front of it. So negative 2 on the left becomes positive 2 on the right. So that is step 2. Yeah, the only difference is step 2 we use a transposition of terms. Yeah, we use that technique to collect variable terms on the left. Yeah, what is the variable terms? Pink and yellow in this case are variable terms. They contain x. The yellow and the green, they are not variable terms because they do not contain variable. Yeah, very straightforward. And now we can combine the like terms, right? Step 3, combine like terms and isolate x. 3x minus 5x, negative 2x. Negative 8 plus 2, negative 6. Multiplication property. We divide both sides by negative 2. Negative 2 is a factor on the top. Negative 2 is a factor on the bottom, so they cancel each other. We have x by itself on the left. On the right, negative 6 divided by negative 2, positive 3. Step 4. Step 4 is not mandatory, or logically is not necessary. If you could guarantee all the steps of your solution is correct. But we have step 4 in the guideline, just to help you to make sure your proposed solution is the correct solution. Yeah. Step 4 check. You substitute. Let's see, how do we check? The original equation 3x minus 2 equals 5x minus 8. You plug in x equals 3. You substitute 3 into the original equation. Let's see if we have a true statement or contradiction. So here we copy everything except x. We copy everything except x. We use a parenthesis. We use parenthesis to hold a place for x, and put a 3 in the parenthesis. Put a 3 inside the parenthesis. So that's how do we substitute 3 for x. We also call that plug in x equals 3, or sometimes we say replace x with 3. They all mean the same thing. Means you put a 3 in the place of x. So let's see. 3 times 3, 9, minus 2. 3 times 5, 15, minus 8. 9 minus 2, 7. 15 minus 8, 7. We got a true statement. So we are certain x equals 3 is a solution of the original equation. The solution set is a set containing one member, one element, 3. Yeah, that is the solution set. If you have a multiple choice question, or if you are required to find a solution set for an equation in a test, then you have to know what does a solution set look like, right? Yeah, we use the braces to be the set and put a solution inside the braces. Braces, okay. So that's number 1. Number 2, we have 5x plus 2 equals 3x minus 6. This problem is very similar with the previous problem. Step 1, simplify each side separately. We skip this step because left-hand side is already simplified. Right-hand side is already simplified. Step 2, collect variable terms on one side. We choose let the variable terms on the left. Okay, so I'm gonna do the same thing. I hope you see the structure of the equation. The equation has 4 terms in it, 2 on the left, 2 on the right. The 2 on the left are blue, yellow. The first term 5x in blue. Second term positive 2 in yellow. On the right hand side, we have 2 terms as well. The pink 3x and the green negative 6. Yeah. Know that you have to include the negative sign as a part of the term. So the green term is a negative 6. We want a pink term on the left. We want a pink term on the left. We want this term on the left. And we want a yellow term on the right. Okay? So we use my transposition of terms. If you haven't grasped that method, I'm going to write the rule here one more time. Transposition of terms means you could move those terms around wherever you want. You can move a term from the left to the right, or you can move a term from the right to the left. Just remember, when you move a term from one side to the other side, you have to change the sign in front of it. A common mistake is you only remember move. You don't remember change the sign, and that is incorrect. Two things in one. Okay, so we have 5x on the left. We're gonna just copy it because it is on the left right now, it's still on the left. We didn't change anything to the blue part. We want the pink part over. So we move 3x over. Positive 3x becomes negative 3x. So you see what happened here. You move the pink part over. You flip the sign in front of it. So 3x is a positive on the right and a negative on the left, right? So you move 3x from the right to the left, it becomes negative 3x. 6x, negative 6, the green one stay. Yeah, I hope you can repeat the video to really grasp this technique. And we want a yellow term moved over. So you just move it, but don't forget to change the sign. Change the sign, flip the sign. So positive 2 on the left becomes negative 2 on the right. Transposition of terms is a very useful, convenient, efficient technique. Now the like terms are together, let's combine them. 5x minus 3x, 2x. Negative 6 minus 2, negative 8. Divide both sides by 2. We have x equals negative 4, right? So step 4, we check the solution. The original equation is 5x plus 2 equals 3x minus 6. We're going to plug in our proposed solution, which is negative 4. We're going to substitute negative 4 for x. So I firstly get rid of the x. I mean, I copy everything in the equation except x. And I use the parentheses to hold the place for x. And then put a negative 4 inside the parentheses. That is plug in, right? 5 times negative 4, negative 20, plus 2. 3 times negative 4, negative 12, minus 6. Simple calculation. Negative 20 plus 2, negative 18. Negative 12 minus 6, negative 18 as well. So that is a true statement. True statement means the solution that we got, which is a negative 4, is the solution of the original equation. Okay, so we can make a conclusion right now. The solution set is a set containing one solution, which is negative 4. Do you have the temptation to write negative 18 here? Please don't do so, okay? The solution that you got is negative 4. Yeah, you see negative 18 here because when we check, we eventually got a negative 18 equals negative 18. That is not solution, okay? Yeah, people made that mistake as well for some reason. Yeah, knowing your solution, the value of x you found earlier is a negative 4. You checked negative 4 is correct, so you put a negative 4 in the set. That is the solution set. Number 3. Let me copy this part. Actually, let me copy 3 and 4 down here. And I could still see them. Then number 3 is 4 times x minus 2 inside the parentheses equals 2 times 2x minus 4 inside the parentheses. Wow, this equation looks pretty complicated, right? So let's recall the guideline, the 4 steps guideline. Step 1, simplify each side of the equation separately. Yeah, we finally could apply step 1 because we need to simplify the left-hand side and the right-hand side for this example, for this problem. In order to simplify each side of the equation, we need to get rid of the parentheses, right? How do we get rid of the parentheses? We use the distributive property. Distributive property tells us if we have A as the coefficient of the parentheses, and inside the parentheses we have B plus C, then we could distribute to get rid of the parentheses. We use A multiplied by B, A times B, plus A times C. That is a distributive property. Let's apply the distributive property to get rid of the parentheses on the left. 4 here is the coefficient. So we're gonna multiply each single term inside the parentheses by 4. We have 4 times x, that is 4x. We have 4 times -2, so be very careful with the sign. The second term inside the parentheses is -2, so 4 times -2, -8. Yeah, remember I said the equality symbol is anchor. You don't change, you just let it stay there all the time. Yeah, I would line up all those equality symbols just to see the change of the terms in the equation. On the right-hand side, we are going to apply the distributive property as well to get rid of the parentheses. The coefficient of the parentheses is 2. So 2 times 2x, 2 times 2x, 4x, 2 times 2x gives us 4x, plus 2 times -4. -4 is the second term in the parentheses, so be careful with the sign. The negative sign go with the term, -4. 2 times -4 is -8, right? So plus -8. Plus -8 actually is just plus -8, right? -8. Okay, so we've completed the first step. The first step, simplify each side of the equation separately. Simplify each side of the equation separately. After that, we have 4 terms, 2 on the left, 2 on the right. I'm gonna color them again like what we did earlier. The blue term, the yellow one, the pink one, the green one. You can use different colors. And step 2, we are collecting the variable terms on the left. So the blue one stay. And then we move the pink term over. 4x becomes negative on the left. So I hope you see this. Seeing this, understand this is the first step. And you practice and you make more sense of it. So we move the pink term over. Positive becomes negative. The green one stay. We're gonna move the yellow one over. Negative becomes positive, right? Yeah, the yellow term is negative on the left, now becomes positive on the right. Yeah, anybody can do that, believe me. It's very useful. On the left, we have a 4x minus 4x. We end up with 0. On the right, we have a -a plus a is also 0. Wow, this is strange, right? It turns out we end up with a true statement or identity. After, when we try to solve for x disappears. X disappears, and we got the true statement. 0 equals 0 is a true statement, right? If that happens, the original equation is an identity. The original equation is an identity. Okay? Yeah, let me say that again. If when you have an equation, you try to solve for x, but for some reason, but x disappears, and you end up with a true statement like 0 equals 0. If that happens, then the original equation is an identity. What is an identity? The equation, the equation is an identity means the equation is true for any values of x. Means no matter what x equals to, the equation is always true. Do you see what I'm saying? Because the left hand side is 4x minus a. If you look at this step, the left hand side is 4x minus a. The right hand side is also 4x minus a. After we simplify, means that no matter what value of x equal to, the equation is always true. That is an identity. If the equation is an identity, the solution set is all real. All the real numbers are solutions of the equation, which is an identity. Identity has infinitely many solutions. They are all reals. Yeah, please repeat this part to really understand it. Number 4, we have 2x plus 5 equals 2x plus 6. Step 1, simplify each side separately. We don't have to do that. And we have 2 terms on the left. I do the same thing again. Blue, yellow, pink, green. And we are going to collect variable terms. We're going to put the blue and the pink together. We copy the blue, nothing changes for that. We move the pink over. Positive 2x becomes negative 2x on the left. Yeah, we have done this many times, so I think maybe you understand what's going on here. The green terms stay, so positive 6 stays there. We move the yellow over. We have negative 5. Because we move one term from one side to the other side, you move it and you change the sign in front of it. So let's collect like terms. On the left, we have 2x minus 2x, which is 0. On the right, we have 6 minus 5, we have 1. Turns out, after we apply a couple of steps, the equation, the original equation, is equivalent to a contradiction. 0 equals 1 is a contradiction, right? 0 is not equal to 1. We all know that. It's a contradiction. The original equation is a contradiction. Yeah, if we have an equation, we solve it, and we got the contradiction, then the original equation is a contradiction. If the equation is a contradiction, the solution set is empty. The solution set is empty. Or we say the equation has no solution. Okay, the equation has no solution. I want you to combine, look at number 1, 2, 3, 4 together. We have actually, we could classify all the linear equations in one variable. All the linear equations in one variable. Give me 1 second. Let me get a table for you. Yeah, let me get this table for you. Copy. Yeah, we could classify all the linear equations in one variable into 3 categories. They are conditional, identity, contradiction. We know what is identity, right? You got a true statement, means that no matter what x equal to, is always true. So that's identity. Identity has infinitely many solutions. The solution set is the real number set, all the real numbers. And earlier, just a moment ago, we also see a contradiction. An equation is a contradiction if it has no solution. Means that no matter what x equal to, the equation is always a false statement. It's not true. No matter what the value of x equal to, the equation, there's no way for the equation to be satisfied. No value of x would satisfy the equation. So that kind of equation is a contradiction. Contradiction has no solution. The solution set is empty. This notation means empty set, empty set, empty set. And for equation 1 and number 1, number 2 that we went over earlier, those are conditionals. Those are conditionals. Conditionals has one solution only. The solution set is a set containing that only solution. So let's go back, look at the number 1, number 2. Number 1, the solution set contains one solution, right? Yeah, so the original equation is a conditional. Yeah, why do we name it? Why do we name that kind of equation conditional? Conditional is because this equation is only true. Left-hand side equals right-hand side. This equation is only true when x take the value 3. Where we say the equation is true only as x equals 3, or under the condition that x equals 3. You see what I'm saying? So the equation is true under a certain condition. The equation is true under the condition that x equals 3. If x equals other numbers, you can try 4, 5, 3.5, -1. Any other values would not make the equation true. Only 3 could make that equation true. So that kind of equations are conditionals. Same with number 2. Number 2 has a solution set containing one solution only. The original equation is a conditional because that equation is only true as x equals -4. That equation is only true under the condition that x equals -4. It is not true for any other values. So that's the classification, or this is how do we classify. How do we classify linear equations in one variable? We have three types of linear equations in one variable. Yeah, please look at those examples. Redo those examples. Let me see if I can find some practice for you. To apply both well, I'll just recommend you work on your assignments. Okay, this is 2.3. Yeah, so work on your assignments in MyLab Math 2.3. You have enough practice there. Thank you guys for watching. Please really watch it on Thursday. Watch on Thursday. Thank you.